Welcome to The Explainer. Today we're diving deep into NVIDIA CEO Jensen Huang's big vision for computing. And let me tell you, it's a future where AI isn't just some new app. It's about to change, well, pretty much everything. All right, so here's how we're going to break it all down. First, we'll get into the massive economic tidal wave that AI is creating. Then, we'll look at how it's literally remaking the world around us. And to wrap it up, we're going to pop the hood and see what kind of engine is making all of this possible. Okay, let's kick things off with a really big idea here. We're not just talking about some new software or a slightly faster chip. No, the argument is that we are in the middle of a complete, fundamental reset of the entire computer industry. So Jensen Huang's point is that this isn't just your normal, predictable upgrade cycle. He calls it a dual platform shift. What does that mean? Well, it means not only are new applications being built on top of AI, but the very way we create software in the first place has been completely flipped on its head. And if you want a number to really grasp the scale of this thing, here it is, $100 trillion. That's the estimated value of industries all around the world that are now shifting their R&D budgets, their core innovation money, and pouring it straight into artificial intelligence. That is a massive redirection of capital. This slide really cuts to the core of what's changing. You see, the old way, that was all about meticulously programming software with specific instructions to run on CPUs. The new way is totally different. It's about training these gigantic AI models that need GPUs to run. And that means we're moving away from apps that are basically pre-recorded to generative apps that create brand new things, text, images, you name it, from scratch every single time you use them.
Okay, so that's the big picture theory. But how does this all translate into actual, real-world changes? Well, it's happening on two major new frontiers, so let's check them out.
First up, we have something called Agentic AI, and this is a really huge leap forward. You need to think way beyond a simple chatbot that just answers questions. We're talking about an AI that can actually do things. It can plan, it can reason, it can solve complex problems all by itself. So instead of just finding you flight prices, it could plan and book your entire vacation for you, from start to finish. And what's so powerful about this is that these capabilities allow an AI to tackle problems it was never ever specifically trained for. It can look at a really complicated goal, break it down into smaller, manageable steps, go out and find the tools it needs, do its own research, and then figure out a solution. The key word here is autonomously. All right, the second big frontier is what's being called physical AI. And this is exactly what it sounds like. It's all about taking AI out of the cloud and the data center and putting it into the physical world. We're talking robots, self-driving cars, and next-generation smart factories. Now, this is a massive challenge, right? I mean, you have to teach an AI the basic laws of physics, just common sense stuff that we take for granted, like gravity, or that if you push something, it moves. And since you can't just let a robot loose in the real world to learn by trial and error, that'd be pretty dangerous, you have to build these huge, incredibly realistic virtual worlds. These are like giant sandboxes where the AI can learn safely before it ever touches a real machine. So that brings us to the final and maybe most mind-blowing piece of this puzzle, the incredible engine that you need to actually power this whole revolution. So think about this for a second. AI models are getting 10 times bigger every single year. And just using an AI, what we call inference, is becoming this continuous thinking process that's always on. So the big question is, how on earth can computing power possibly keep up with that kind of insane, explosive demand? Well, here's the answer. It's called the Vera Rubin platform. And the key takeaway here is that instead of just building a faster GPU, NVIDIA has gone back to the drawing board and re-engineered the entire system. You're looking at 6 separate breakthrough chips here. You've got the Vera CPU and the Rubin GPU at the heart of it, sure, but then you have all the networking and data processing chips that connect everything together. They were all designed from the ground up to work in perfect harmony, as one single supercomputer. That level of co-design, that's the secret sauce. And this cable really shows you what that co-design is all about. Look at the Rubin GPU. It delivers a 5 times performance leap over its predecessor, Blackwell, which is already a beast. But here's the real kicker. It pulls that off using only about 1.6 times more transistors. Now, normally, a jump like that would require way, way more. This insane efficiency gain is exactly why they had to reinvent the whole system, not just one part of it. So what does that actually mean in the real world? Well, this chart spells it out perfectly. If you wanted to train a massive, next-generation AI model with 10 trillion parameters, it would take about 4 months on the current top-of-the-line Blackwell platform. With Rubicy, you could do it in just 1 month. That's a 4x speedup that will just dramatically accelerate the entire pace of AI innovation.
So when you put it all together, you see that the goal here isn't just about making faster chips, it's so much bigger than that. It's about a full-stack reinvention, from the silicon itself to the systems, the infrastructure, the models, and finally to the applications that are going to change our world. It's about building a platform that lets any company in any industry build its own AI.
And that really leaves us with one final, pretty staggering thought. The progress of AI is directly tied to the power of the computers we build. So if this is the engine we have today, what becomes possible tomorrow? As this engine gets exponentially more powerful year after year, the question stops being if AI can do something, and it becomes what are we going to ask it to do next?